Well, let's get into this one right here. So let's go ahead and grade this homework on polynomial functions where we're going to talk about turning points, shall we? So to start with, what I did is I went ahead and I plugged all of these into Desmos, so I'll show you the actual turning points on the screen capture here in just a minute, but let's go ahead and do this part together right now. So let's see, instructions are important, right? So fill out the chart below to find the actual number of turning points. Use a graphing calculator or software like you can find on our good old buddy DESMOS, right? Desmos. All right. So the degree, well, the degree for this one's not actually 2, it's going to be 3. And here's why. When you multiply this binomial, when you multiply, this is a binomial, this is a trinomial. When you multiply this quadratic times this binomial, well, x squared times x is going to be x to the third, so our degree is going to be 3, right? Maximum number of turning points. Well, the maximum number of turning points is 1 less than the degree. So the most turning points we're going to have is 3. We could have 3 x-intercepts. We could have 2. We could have 1. Right? So, yeah, now the actual number of turning points. Let's go ahead and see what Desmos has to offer for us here. So here's what we got. Our first graph is right here. Oh, man. So this is kind of strange looking right here. We're going to have to zoom in. So you just use your mouse to zoom in. So turning points are where the function changes from increasing to decreasing. So right here it's increasing. Somewhere in here it's not going up or down. It's just somewhere in here it's going to be horizontal just for a moment, and then it's going to go down again. So that's one turning point. Well, here you see it is going down. It doesn't go up very far. Like, we can adjust the y-axis to really show this. So we could do like, oh man, let's see how we can do this. Let's see if that'll do it for us. Oh, there's too many decimals in there. Oh yeah. So you can see it is going up, and then it goes back down again. Do you see? And then it starts going up. So there's one turning point here and another turning point right here. So here there are the two turning points. So there are 2 turning points. Yep, 2. All right. So let's go ahead back to our worksheet right here. There are actually 2 turning points, which matches the maximum. Now, next one, it says the degree of this one's a little more straightforward. The degree of this one is 4, right? The number of turning points then, the maximum number of turning points is going to be 3. Let's go ahead and take a look at what this one looks like. So, looks like we have 1, 2, 3 turning points. So we do have 3 turning points right here. And on Desmos, it's kind of nice. When you click on the curve, it will put some dots on some points of importance. And those turning points are some of those points. So here it's going down, then up. Right now it's going up and then down. Still decreasing and then turns to increasing. That is 3 turning points. So we had 3 turning points for that one. All right, next up, Buttercup. The degree of this one is 5, which means there's a maximum of 4 turning points. And so if we look at this one, let's go ahead and turn the screen out, that one off. This one, it has a maximum of 4 turning points, but it only has, wait a minute. Look at that. When I was zoomed in, look, when I was zoomed in, I didn't see the sides. This is potentially possible. But there's a clue that this is wrong. You see, this is going up from left to right. And what we're going to see in the near future is that when the leading coefficient's negative, this is actually going to be flipped over. So this is actually going to be going down overall from left to right. So let's zoom out. Look at that. Oh, that's a funky looking graph, right? So it looks like we have 1, 2, 3, 4 turning points. So it's going down and then goes up. That's 1. It's going up and then down. That's 2. Going down and then up, that's 3. Up and then down, that's 4. So this one in here, it might be a little confusing, but when we zoom in, you can definitely see that's another turning point. So this function right here also has 4 turning points. All right, the degree of this one's 2, right? The maximum number of turning points is 1, and it's going to have 1 because it's going to be the vertex. We don't even need to graph it. We can, but we don't need to graph it. It's quadratic. Quadratic equations always have a vertex, and that vertex is the turning point. So there we go. All right, now, next up, it says state the intervals where the graph is increasing or decreasing. So right here it's decreasing and it turns increasing. So we have to state those intervals, right? And then it says to state the possible degree of the polynomial function. All right. Well, so let's do that. So increasing. So this one's increasing from here, which looks like from -1 to infinity. This is increasing. Do you see? Because right here it's going down. It's decreasing because you read a graph from left to right. Here it's increasing. All right. So from decreasing, it's going to be from -infinity to -1. That looks like it's going to be at -1 right there, that turning point. Estimating that, we don't know for sure because we just have a picture. So we don't know what the function is. We don't actually have graphing software making this graph. It's just a screen capture of it. So I'm going to assume that's at -1. All right. Now the possible degree. Well, you see how well, first of all, it has to be more than 1. We have 1 turning point. So it has to be at least 2. Do you see? It has to be at least 2 because we have 1 turning point. We also have 1, 2 x-intercepts. So the degree has to be 2 or more. Now, one of the things you're going to find out soon, you haven't seen it yet, is that one of the things you're going to find out is this is going to have a degree that's even. It's going to be 2, 4, 6, 8, or some even number, 2 or more. You don't know why yet, but it is true. It's going to be coming very, very soon. But for right now, with what you know right now, following the program as we've set it up here, 2 or more. Now, let's go ahead and start off with the degree of this one. Do you see how this has 1, 2, 3 x-intercepts? So it has to at least it has 3 x-intercepts. So the degree at least has to be 3 based on that information. But look at the number of turning points. 1, 2, 3, 4. We have 4 turning points. So we have 1, 2, 3 x-intercepts. We have 4 turning points. 4 turning points. So the number of turning points is 1 less. The maximum number of turning points is 1 less than the degree. So the degree has to be at least 5. Now, one of the things we're going to find out also in the near future is that this is going to be an odd degree. This will be even and this will be odd. You'll see why soon. Coming up soon, you're going to find out why. This is odd degree and this is an even degree. Okay. So even though there were 3 x-intercepts, the degree cannot be 3 because of the number of turning points. If the degree is 3, the greatest number of turning points would be 2. Do you see? So it's not 3. Even though there are 3 x-intercepts, the degree can't be 3. It has to be 5 or more. All right, now, increasing. Well, it's increasing from -infinity to whatever this number is right here. So let's say -0.9. Yeah? And then it's also increasing from, let's say that's -0.62 all the way until we get to here. And let's say if that's 0.5, let's say positive 0.6. And then there's another place where it's increasing from here, which is like 0.9 to infinity, because it's increasing forevermore after that. We're assuming this picture is the complete picture of the graph, right? Okay, so we have 3 intervals where it's increasing. Now, we will also in the near future learn interval notation, but for right now, that's all we're going to do, okay? Now, decreasing, it's going down from left to right. So it's decreasing from here to here, and it's decreasing from here to here. We have 2 intervals where it's decreasing. So let's say if we said that was -0.9 to 0.6, -0.6, right? Right here, we said that was -0.6. We're kind of guessing those numbers, right? As long as your guess is reasonable from a graph like this, you're going to be all right. A lot of the time what will happen is they'll give you a very large graph and you'll have to count more carefully. So we said this one was 0.6 here to 0.9. Those were the intervals of where this thing was decreasing. So anyway, let me know how you did. If you have questions, just leave them a comment. I'd be very happy to help you guys out. Hope this has been helpful, and you guys be safe. I'll talk to you guys later.